Hello and welcome to SQL Server Analysis Services 111, Aggregation Basics and Analysis Services 2005. This particular video is specific to Analysis Services 2005 because building of aggregations has changed quite a bit from 2005 to 2008. Concepts are the same, but the tools are a little bit different. So in this video I'll cover how to create aggregations in 2005. Aggregations are a fairly deep topic and I could go a lot more into it, and I will in future videos, but this is just the basics for what you want to be doing getting started in a project. And if you think about it, in the previous videos you have gone through and designed the dimensions and then the measure groups, and you've tied measure groups to the dimensions, and you've designed or added attribute relationships. And we've been through all of that, and so now it's time to actually add aggregations. So what are these aggregations? Well, they're one of the primary reasons you build cubes in the first place. If you think about it, your relational data warehouse, everything is at this lowest level of granularity. Your fact table probably includes individual transactions, or at best might include the sales per day, per product, per customer. And so it's very low level detailed data. What you want are higher level summaries. So when a user comes in and asks for the data, it doesn't have to go through potentially billions of records in order to get a sum. It simply pulls it from an aggregation because it's been pre-calculated when you did the processing. So these greatly speed up queries, and therefore obviously they are one of the major aspects of cubes that you want to have in there to speed up these queries and make it much more usable. Well, what you've done so far, if you've been following the videos, you've built cubes and you can browse them and they seem very fast, but you actually don't have any aggregations yet. When you build dimensions in a cube in BI Dev Studio, there aren't any aggregations by default. So you have to go in and add those. And the good news is that there is a wizard that will walk you through the process, and it tries to determine what aggregations it should create, and it creates some for you. Now, it doesn't always do a perfect job, but especially on smaller cubes like you have with the AdventureWorks sample, it doesn't really matter. So what I'll do when I get into this, I'll go to the Cube Designer, I'll double click on the cube in BI Dev Studio and open the Designer, and then you'll go to the Partitions tab. I haven't been to that tab yet. I haven't really talked about partitions. That'll be a later video, but you'll go to the Partitions tab, and this is one of the differences, by the way, in 2005 and 2008. There's a separate Aggregations tab, but again, for 2005, go to the Partitions tab, and then you have every measure group listed, and when you choose the measure group you want, there's a Design Aggregations link, and then you can start the wizard and run through and build these aggregations. So I will get into that here in just a moment and show that to you. Now, like I just said, aggregations are by partition, and a partition is a piece of the data for a measure group. Now, it may be the whole measure group, and in fact, in all my previous examples, I haven't created individual partitions, so there is a single partition per measure group. That's just a physical file out on the file system that's storing data. So whether you have one partition or multiple partitions per measure group, it doesn't really matter here. I'll go in and show you what this looks like. The benefits of partitions are, there are several. One is that they can be processed independently, so you can process just the latest partition, and most of the time partitioning is done by time. So let's say that you're doing 12 partitions, one for each month. Well, you can process only the current month's partition, leaving the others untouched. And in addition, each partition can have a totally separate aggregation design. So let's say that you have 10 years of data, but 90% of your queries are on the last 2 years. Well, you can build those with a much higher level of aggregation, and then the previous 8 years that aren't used as much, they have a much lower level. So what, they're a little bit slower, they're hardly ever used. And then that can help you with disk storage, and if you ever have to reprocess the old data, it will process much faster because it has fewer aggregations. Now, one of the things you'll see when I get into the wizard here in just a moment is it will ask me for counts. It will ask me for counts of the dimensions and the measure groups and the number of records in these. Now, if it's a small data set like with the AdventureWorks that I'll show you here in just a moment, of course, letting the wizard count for you just takes a few seconds, and that's fine. For very large cubes, if you told the wizard to go and count everything for you, it could take a very long time. It could take hours potentially to do that. I mean, basically it has to do a select count on all of the attributes and all of the fact tables. So it can take a long time. So if you have a large cube, you can just manually type in the estimates. You don't have to let it count for you. And if you are, whether you let it count or not, if you're looking at a sample of the data, let's say 1/10 of it, then you should go in and put in what the size should be. It uses these counts to help determine how to build the aggregations and which ones to create. So these don't have to be exact, but you should get them relatively close. And again, I'll show you this part of the wizard, this step in it, in just a moment. Now, there is a wizard for designing aggregations, and when I get into it in a moment, there are actually 4 choices. I can design aggregations up to a certain amount of disk storage, or up to a certain percentage, which is what I usually do. I can also do it until I click stop. And you might think that sounds odd, but I actually have worked with customers before where they start the aggregation design wizard and they go to lunch and they come back an hour and a half and several martinis later, and it might only be up to 1 or 2%. So it's a very slow process on large complex cubes. I don't want to say very slow. They had some other challenges with their data, let's put it that way, but it can be slow. Now, the wizard doesn't know how the data will be viewed. It doesn't have any way of knowing that. So it assumes that all queries are equally likely. So what I normally recommend to people when they're getting into this is, look, start with 20%, and then later we'll use the usage-based optimization wizard, the UBO. And I'll have a whole video on UBO later, but what the usage-based optimization wizard does is it allows you to monitor queries. It logs them as people are doing them. So rather than just assuming all queries are equally likely, you're logging actual queries. Then you run the usage-based optimization wizard. It looks at this log and it determines what aggregations would have best answered those queries. And if they don't already exist, then it can create them for you. So a very interesting tool, and again, I'll cover that in a later video. Now, I said to start at 20%. You might say, well, I'd go to 100% and create every possible aggregation. Well, the wizard doesn't create every possible aggregation. It uses what is called the 1/3 rule, and some people call this the 30% rule. Now, I know that 30% and 1/3 are not the same. It's approximately somewhere in the 30 to 33% range. So just generically, it's kind of called the 1/3 rule. And what this says is the aggregation wizard will only create aggregations if the size of that aggregation table it's going to create is 1/3 the size of the fact table or smaller. So in other words, it's not going to create a fact table that's half the size, or I'm sorry, an aggregation that's half the size of the fact table. And it does this because it says, look, if I have to read all those records and create them and store them, I might as well just go read the base data. So if you look at this example, I know the numbers are somewhat small and hard to read, but I have created some dimensions here. These are actually hierarchies in a dimension, but you notice that, for example, I have 4 years of data, which means 8 semesters, 16 calendar quarters, 48 months, 1,461 days. I have the customer geography dimension, and you'll notice again the numbers here climbing dramatically. I have 5,000 state provinces, 500,000 cities, 2 million postal codes, and 20 million customers. Again, these are just made up numbers for an example here. Product categories, I have 20 categories, 300 subcategories, and 10,000 products. I recently did work with a company that had over 1 million SKUs in their product dimension. So you can see how these numbers get quite large. And the fact table in this example, again, simple example, it's all in a single partition, 50 million records. Now, if I looked at this and using that 1/3 rule, if I said, okay, I have in an aggregation I want to create it, I want to include the individual customers. Well, the wizard will not create that aggregation for me. It says, hey, look, you've got 20 million individual customers. I only have 50 million total records. That's over 1/3. I'm not going to create it. If I said, okay, let's have an aggregation. Again, you don't have this control with the wizard, but I'm just saying that if you, following the wizard's logic, if it said, okay, could I create an aggregation that's state, province, subcategory, which I've abbreviated here, and year, it could create that. 5,000 state provinces times 300 subcategories times 4 years. That value is less than 1/3 of 50 million, 1/3 of the fact table. So it could create that particular aggregation. But it would not create state, province, subcategory, and month, because that value actually it's greater than 50 million. It's not just greater than 1/3 of it, it's actually 72 million. So you can see from this that behind the scenes the wizard is using some logic. And I point this out not because you know, I mean, okay, you could go to a cocktail party and talk about the 1/3 rule, and I'm sure people would really be impressed. But the reason I do this is that some people think when they get into the wizard, oh, I'll go to 100% and it will calculate every possible aggregation. Well, it doesn't. Notice here, there are a lot of aggregations it won't create because of this 1/3 rule. Now later in future videos, when I talk about creating aggregations manually, there is no 1/3 rule there. You could do whatever you wanted. And in fact, you could create something like this aggregation of state, province, subcategory, and month that could be very, very large. And by the way, these values here, of course, these are only possible values. You obviously aren't going to have more values in aggregation than you have in your fact table, because at best it would be a 1-to-1 relationship. But I'm just showing you the possible number, and that's all the wizard has to go by really here is, well, gee, I know how many I have in the fact table, I know how many I have here, but potentially it could be these sizes, so it won't create those. But enough of these slides. Let's take a look at creating this, and the good news is it's fairly simple to start creating aggregations. And then later you can again fine-tune them with the usage-based optimization wizard, and then of course for the truly advanced stuff you can create your own. Now here I am in BI Dev Studio, of course 2005, and this is actually the sample from Microsoft, the AdventureWorks sample cube. It's just a little bit more complex, of course, than what you've seen in the previous videos, but don't worry about that. The only reason I did this is because it does have multiple partitions, and that adds one step to the wizard, and I just want to point that out to you. So again, if you're starting with a blank screen, what you'll do is over here in the Solution Explorer, you'll double-click on the cube. That opens the cube designer here, and you'll go to the Partitions tab. Now, this is where it's different from what you've done so far. If you come here from the project that I've been doing in the previous videos, everything that you have will have just one dimension. Okay, you'll just have 2 measure groups, maybe 3 measure groups, and you'll just have a single partition for each one. But here in the Internet Sales, for example, they have 4 partitions. Now these are partitioned by time. If I hover over this, you'll see the tooltip pop up, and you'll notice the where clause down at the bottom. Let me get it pop back up. Is simply order date key of less than 184. I only have half a year in the first year, so it just is the first 184 days. Now from 185 to 549, that's the next year's worth of data, and so forth. So each partition is just breaking it apart into a separate year. Notice this already has some aggregations designed for it just because I've worked with it in the past, but what you're really interested in is this Design Aggregations link here. So clicking on that, of course, it welcomes me to the wizard, which is very nice. And I'll click Next, and this is a screen you will not get if you have only a single partition. It says, okay, you're about to build some aggregations. Which of these partitions you want to apply it to? You could do just one or any combination of them. I'll just choose all 4 just to get them started. And then I'll click Next. And don't worry about this storage and caching options. Again, a whole nother video later on what this is. Just leave it set to MOLAP for now, and click Next. And this is really where you get into the meat of the aggregation design wizard. Now this already has counts for me. If it didn't, I could click Count and it would count those up. When you have multiple partitions and you choose multiple partitions, this partition count here is only the first partition. I don't know why it happens to work that way, but there are a total in this measure group, a total number of records of 60,398. I could then expand each dimension if I wanted and look at the number of values in these different attributes. I'll grab customer here just because it has some higher numbers, and you can see that I have 18,484 customers. Now at this point, again, if I were working with a subset of the data and I knew that my real data was going to be 10 times the size, I would manually adjust these numbers at this point. And again, they don't have to be exact, but just relative to each other, they should be fairly close. But since this is small, I can do the count and get the actual numbers, that's fine. I'll now click Next, and this is the screen where you actually make those 4 choices that I mentioned earlier. You have the options of designing aggregations until reaching a certain file size, and that can be in meg or gig, until the performance gain reaches some number, till I click Stop, or don't design any. Some people don't design any at first, and they just let people use it for a while, and they use the usage-based optimization wizard to create the aggregations from scratch, without starting with any. Normally, I come in and I use this performance gain reaches, and like I said, I like to start at 20%. Just a rule of thumb. You can go higher or lower depending on how large your cube is, but 20% seems to be a pretty good starting point. And remember, I can go all the way to 100 on this, obviously, but it's not going to do every single one. There's the 1/3 rule to consider. But let's start with 20% here, and I want to point out a couple things from it. This is a great tool too, by the way, because you can, on large cubes, you can run it and you look busy and you can be doing something else, of course, while it's running. So I'll click Start, and what it's going to do is examine my cube and my counts and try to determine then what aggregations it should build for me. And you see it has now started, and it is designing these aggregations and figuring out what optimization level it's to. And so there you have it, 20%, and it designed 21 aggregations, and the storage size is a whopping 21.4 KB, so kilobytes, very small amount of information. Remember, this is a small cube we're working with, so it's really not that big a deal. But I want you to consider what it's going to do here, and in fact I'm going to open up everyone's favorite editor here, and let's jot this down. So at 20%, 21 aggregations, and a size of, what was it, 21.4 KB. So let's blow this font up. So 20%, 21 aggregations, 21.4 kilobytes in size. Let's double that. Let's go from 20 to 40%. I can simply change that to a 40 and hit Continue. And now it's going to try to go from 20% to 40%. And you'll notice that just doubling that number tends to have a much larger impact on the number of aggregations and the storage size. So you can see from this that at 40%, we're now talking about 72 aggregations at a storage size of 100.4 kilobytes. I know, again, still small, but you can see the difference in these two is quite dramatic. And now through the magic of video editing, I'll show you just what it would be at 100%. And the wizard is now done, a very exciting 2 or 3 minutes on my side. You can see that to go to 100%, there are 160 aggregations, and the size has ballooned to 3.1 megabytes. Now it stopped at 99%. It couldn't go all the way to 100, but it's close enough at this point. So you can see that obviously there's a diminishing marginal return here. There's this huge inflection point that will get you about 70% in just this number down here is the storage size in less than a third of a meg. You'll get 70% of the total performance gain that aggregations are going to be able to give you. Again, with that 1/3 rule in effect. So very much an inflection point here, and then certainly not a flat curve the rest of the way, but relative to this line here, it is certainly flattened out. So I'm just going to do a quick reset on this and go back to 20 and then finish the wizard. And again, a little video editing to jump right to this point. So now I can click Next, and you're asked a question: do you want to go ahead and deploy and process these aggregations immediately, or you just want to save them, and the next time you happen to deploy, it will go ahead and process them? Obviously, on a very large system, you've done this for the first time, deploying and processing can take hours. So normally, well, just depends on the size of your cube. You may well leave it at the save the aggregations but don't process them. Here I have a very small cube, so there's no problem if I go ahead and say go ahead and deploy and process these now. And of course finish is the only thing I have. And again, I'll do a quick pause here and let it go through the building process. Now, because I know you won't be able to sleep until you have actually seen this, when the processing has occurred, you'll notice that here, of course, in this case, there are multiple partitions, but if I go through and expand these, of course, each one gets its own query, and it simply has that where clause on the end to only pull the data that matches that particular partition. But that's it. I've gone through and processed this now, and that's it. It's ready to be used. I don't have to do anything different in my queries. The engine will figure out if there is a partition that can improve that query. Much like on the relational side, when you have built indexes, the query engine is supposed to be intelligent enough to figure out which index to use if one will help speed up that particular query. So again, that's it in 2005. That's the basics of building these aggregations and a little bit about what it's doing behind the scenes. Future videos, I'll get into customizing those aggregations if you need to in any way. And also, when you're running queries, how do you know if it's using an aggregation or not? That often is what drives you to then have to go create aggregations manually. And of course, I'll do a future video on the usage-based optimization wizard. So that's it for 2005. If you're using 2008, I'll have a video of that up hopefully in the next 24 to 48 hours from finishing this. So in summary, no aggregations by default. BIDS just doesn't create them. You have to go through the process I just showed you. Aggregations are on a per partition basis. Everything we've done so far has been a single partition. I just used a project here with multiple ones to show you that first screen in the aggregation wizard. If you've got a small enough data set, let the aggregation wizard count the records for you. Simple, you just click one button, run some queries for you against the relational data warehouse. If it's large, just put some reasonable estimates in there. Again, they don't have to be exact. And again, a rule of thumb, find what works best for you, but for a lot of people, I start with 20%, and then later I'll run that usage-based optimization wizard to try to give them some better aggregations that actually match their query pattern once we've had a chance to log and see what those queries actually look like.